Hello, everyone. Welcome back. Today, I am going to be talking about solving linear trigonometric equations. So let's get into it. All right. So the first thing we're going to do here is let's take a look at this question. It says, solve the equation 5 sine theta plus 1 is equal to 0 on the interval from 0 to 2 pi. So let's do that. First step is let's just rewrite our question. Then I'm going to subtract 1 from both sides. Then I'm going to divide by 5. And then we are going to find theta, which theta is going to be inverse sine of negative 1/5. And also make sure your calculator is in radian mode, because if it's in degree mode, then you won't get the right answer here. So sine the inverse negative 1/5 in radians. Let's see what that's equal to. So that gives us 0.2. Okay. So then we've got to figure out the rest of the question. We've got to figure out what our theta values are for this. So we know that our answer for sine theta was negative. So that means that we can't be in quadrant 1 or quadrant 2. We must be in either quadrant 3 or quadrant 4. And how do we know that? We know that because of the cast rule. And the cast rule states that in quadrant 1, all three of the ratios are positive, right? Sine, cosine, and tangent are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive, and in the fourth quadrant, only cosine is positive, okay? So in this case, since sine is something negative, negative 0.2 to be exact, we need to, figure out where it's going to be. So it's going to be over here, with this being 0.2, and over here, with this being 0.2, right? So this one is clearly, right, if we have 0, pi over 2, pi, and 3 pi over 2 like that, this is clearly pi plus 0.2 as our first solution, right? So theta is equal to pi plus 0.2, which is equal to approximately 3.34, right? Because pi is about 3.14, so this one would be 3.34 approximately. And then this one here would be the full 2 pi, right? We have 0 and 2 pi here as well. It would be the full 2 pi. Subtract 0.2, which gives us about 6.08 left. And so those would be the two solutions. Now, of course, there's infinite many solutions if we had an infinite domain, but in this case, they didn't tell us that we had an infinite domain. They just told us to do it with respect to the very first rotation, right? They said just go from 0 up to 2 pi and then stop there, okay? And so that we did. Okay, the next one says solve this equation on the interval from 0 to 2 pi. So this one is going to be quite similar to the last one, which is good. First, we're going to let 4 theta equal to x, and then we'll solve for it back in the end. So let's do that. Let's let 4 theta equal to x. So in that case, we have 3 sine x plus 2 is equal to 0. So therefore, sine x is going to be equal to negative 2/3. And so x is going to be equal to 0.73. And now we could go back and find what theta is, because if x is 0.73, we could divide that by 4 to get theta, right? And so we will do that at the end, and we'll talk about that in a bit. So this one is also sine, and this sine also got a negative value, which means the same thing as last time, that we can only use quadrants 3 and 4, so we're going to ignore quadrants 1 and 2 for that reason. I'm going to draw my grids a little bit smaller this time just to give us a bit more room. It's important to draw them, but they don't have to take up the whole space like mine did last time. And then here we have 0.73, and then here we would also have 0.73. And let's label those. Okay, so for this one, clearly we have pi plus 0.73, which that is going to be equal to about 3.87. Okay, and then the second one, we have 2 pi, right? We have our full 2 pi rotation minus 0.73, which is going to give us, let's see here, about 5.55. So there we go. Now that we have our x values, we just need to solve for theta. Okay, so we know that 4 theta is equal to x, so 4 theta is equal to 3.87, which means theta is equal to 3.87 over 4, which means theta is equal to 0.97. So there we go, there's answer 1. Answer 2 is going to be that 4 theta is equal to 5.55, which means theta is equal to 5.55 over 4, which means that theta is equal to 1.39. And there we go. Awesome. Okay, and let's move on to example 3. Example 3 says, solve this equation. 4 secant theta plus 2 is equal to 1 on the interval from 0 to 2 pi. Okay, so let's start by isolating secant theta. Okay, so here we're going to have, if we expand this out, we're going to get 4 secant theta plus 8 equals 1 by the distributive property. Then let's move the 8 over to the other side. So we're going to get 4 secant theta is equal to negative 7, which means secant theta is equal to negative 7 over 4. Now, what is secant theta again? Well, secant theta is the reciprocal of cosine, right? So that means that cosine theta would be the reciprocal here, which would be 4 over 7, not to be confused with the negative reciprocal. We don't need to add an extra negative. That's just for slopes and finding the perpendicular slope. So that's separate, but that is a common mistake I see students making. So this is not to be confused with the negative reciprocal. This is just the reciprocal, where we just flip the numbers. We don't do anything with the signs. Okay. So now let's figure out theta. Theta is going to be equal to 0.96 if we punch in, using our inverse cosine function, right? So if we look for cosine inverse on our calculator like that. Okay, perfect. So now we are going to figure it out. So in this case, we have cosine, and we have a negative thing for cosine. So where is cosine positive versus negative? Well, let's see. Cosine is positive in quadrant 4 and quadrant 1, and it's negative in quadrant 3 and 4. So that means we're going to focus, on 2 and 3. So we're going to be focusing on quadrants 2 and 3 today. So let's draw this one here. This one is going to be 0.96. And then here we're going to, I erased that by mistake. Here we're also going to have 0.96, right? So that's what we're going to have there. All right, and we're going to ignore A and C because these are quadrants where cosine is going to be positive, and cosine clearly is negative here. It's negative 4 over 7. Okay, so with all that said, what is theta then? Well, theta in this case, we have 0, pi over 2, and pi, 3 pi over 2, right? So in this case, it's going to be pi over 2, it's going to be pi minus 0.96 is going to get us this first angle here, this first theta. And so that's going to be equal to 2.18 approximately. And then over here, it's going to be pi, right? Pi plus 0.96 to get this full theta. And that is going to be about 4.1 approximately. And there we go. We figured it out. All right, let's do one more word problem today. Or I guess one word problem. I guess these other ones weren't word problems. So let's do a word problem related to this as well, because some questions on the test, hint, hint, might be word problems for this. This one says the high tide in Matthews Cove in New Brunswick is at midnight. The water level at high tide is 7.5 meters. The depth d meters of the water in the cove at time t hours is modeled by this equation. D equals 3.5 cosine pi t over 6 plus 4. Jenny is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver her sailboat safely. At what times will it be safe for her to sail to Matthews Cove? Okay, so what's the first thing we need to do here? We need to set D to be at least 2, right? D needs to be at least 2 in order for the sailboat to be safe. So first we're going to find where are the turning points, right? Where are the exact points where it's exactly 2, right? That's going to help us find kind of, well, I shouldn't say turning points. That's not quite the right word, but the points where, those, I guess break even points could be a good way to put it. Those break even points for us. Okay, so to do that, let's plug in 2 for D because the sailboat must be exactly 2 meters deep or higher, right? It needs to be at least 2 meters deep, so either exactly or more for it to be safe for the sailboat is 3.5 cosine pi t over 6 plus 4, and then let's solve. So first I'm going to subtract 4 from both sides, and I'm going to get negative 2 equals 3.5 cos pi t over 6. So that means negative 2 over 3.5 is going to get us there, which that's going to be 4 over 7, which is going to be negative 0.571. And then here we have cos pi t over 6, which is good. Okay, and then we have cos theta, right? Let's let theta equal to pi t over 6. So we have cos theta is equal to negative 0.571. Then let's give that a punch in our calculator and find out that theta, therefore, is equal to 0.962. Okay, awesome. So now let's figure out the different values we could have for theta given the situation. So in this case, cosine is what we're using, and cosine is negative, right? Cosine is negative. And so our first answer is going to be in quadrant 2, and our second answer will be in quadrant 3. I'm just going to label these. Awesome. Okay. So let's ignore the quadrants where cosine would be positive, because in this case cosine is negative, keep in mind. And we're just going to pay attention to where it's positive. So we would have something here and something here, right? So here we would have 0.962. And here we would also have 0.962. And I would like to find the full theta for both. So this one's full theta is going to be pi minus 0.962. And this one's full theta is going to be pi and then plus that extra bit, that 0.962. So over here, if we punch that in our calculator, we're going to get 2.18. And over here, we're going to get 4.102. So now we've solved for theta. So now we need to solve for t. What's the time? So we know that theta 2.18 is equal to pi t over 6. And over here, 4.102 is equal to pi t over 6. So now we've got to solve for t. So in this case, t would be 4.17. Over here, t would be 7.84. Okay. All right, so what times then? Because they said this in terms of the times. Let's go back to the question to figure it out. It says it's modeled t hours. The time t in hours is modeled by this equation, and it's the level after midnight. Okay. All right, so this is how many hours after midnight. So this first one is 4.17, so that means 4 hours after midnight plus 17 out of 60, however many minutes that corresponds to be. And that is going to be 10 minutes approximately. So that would be 4:10 a.m. is the first time where we hit exactly 2. And then this one would be 7 hours, so 7 something, and 84 out of 100, which is what over 60? About 50 over 60. So 7:50 a.m. like that. Okay. So now let's draw it out. Let's just review actually some of the things they said in the question that are going to be relevant to us, because we spent all this time kind of figuring out where are the points where we're going to be at exactly 2, and I forgot the rest of the question. Okay, so what did it say? It said that the water level high tide is 7.5. Okay, so that means the maximum is 7.5, so we learned that. Oh, wait, they gave us the whole equation. Okay, so never mind. Okay, so we have plus 4 at the end, which means the midline is going to be at 4. Okay. We also have that the amplitude is 3.5, which makes sense. They said high tide is 7.5, right? So adding 3.5 would get us to 7.5, and subtracting would get us to 0.5. So those are our minimum and maximum points, so that's going to be important. And we start at midnight. We start from 4 at midnight. And then it says that it's a cosine function. Okay, it's a cosine function here. All right. Well, that sounds good. That sounds like we know what we need to know about this. All right. So we start at midnight. And the water level is at high tide. Or no, the water level at high tide. Oh, no, they're saying the high tide is at midnight. Okay. So then we're not starting at 4. We're starting at 7.5. We're starting at 7.5, which makes more sense for a cosine function as it is. So we're starting up here at 7.5 right at midnight. So let's say that this starting point is midnight. Then here we have 1, 2, let's make those nicer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 till midday. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So the first significant point I want to point out here, it's going to be around this point. This is not our midline. This is just our line for when it gets under or over 2. So at 4:10, it touches this line. Okay, so 4:10, let's say that's right around there. It touches this line, right? Because that's one of the times we found. And then 7:50, it also touches again. Okay. So now let's draw this, right? If we were to draw this, we're going to get something like this. And so therefore, the times that it is safe for the sailboat are going to be between, let's see, when is the water going to be at least 2 meters deep? So 2 meters deep or deeper, I believe. Yes, they said that she needs the water to be at least 2 meters deep for her to maneuver her her sailboat safely. Okay, so you want for it to be 2 or higher. So therefore, this area here between 4:10 and 7:50 p.m. Oh, sorry, this shouldn't say a.m. Oh no, it should say a.m. We're good. Sorry. This time between 4:10 a.m. and 7:50 a.m. is not going to work. Every other time is going to work. Okay, so therefore, these times they work, and then these times do not work. Right. So therefore, it is safe to use the sailboat from 12 a.m. to 4:10 a.m. and then again from 7:50 a.m. to, well, you know, until we restart basically, right? Until we restart again. So until 4:10 p.m. until it hits then again, right? Because actually, we didn't really discuss what the period length was, but the period length, as it turns out, is 12 hours. So this does a full cycle after 12 hours. So we would have to wait up until, the same time again at p.m. in order for it to start being unsafe again. So that's pretty good news. Pretty much all day, as long as you don't do it in the evening, I think you're good. You're pretty good. All right. Or I guess later afternoon to early evening. But yeah, that's about good. Okay, well that is it for today. Good work today, everyone. Next day we'll be doing the very last lesson in this course ever for some review and also to talk about solving quadratic trigonometric equations. So I will see everybody for that one. Good work today, everyone, and we'll see you then. Bye, everyone.